Today we're talking about 4.4, section 4.4, part 2, a couple theorems. The mean value theorem for integrals. We have one for derivatives, but now we have one for integrals. The mean value. If f is continuous on a closed interval from a to b, then there exists a number c somewhere in a to b such that the integral from a to b of f of x dx, which remember represents the area under the curve, so this area under this curve from A to B. So this area from A, I'll use a different color, from A to B, this whole area would be equal to the area of a region that's rectangular that has the dimensions f of c, which is a y value, so let's say this is c right here. So this would be f of c times the width of the rectangle from a to b, so b minus a. So they're saying that the area under a curve would equal the area of a rectangle, so this region would be approximately equal, well, exactly equal to this region, but my drawing isn't exact, if we can find that perfect value c. So there is, this theorem guarantees that somewhere between a and b there is a place where we could put c so that this rectangle represented by the height of c and the width a to b would be equal to the area under the curve from a to b. Now the mean value theorem is called an existence theorem. It just tells you that it exists, and then sometimes you have to actually find it. So if we have an example where it says find the value of c that's guaranteed by the mean value theorem for a function, let's say we have the function 9 over x cubed for the interval from 1 to 3, the mean value theorem says first of all f has to be continuous. Well, f is continuous everywhere except at 0, because you can't have a 0 in the denominator, but 0 is not between 1 and 3, so f is continuous in the closed interval from 1 to 3. So we know we can use the mean value theorem. That's the only condition, okay, that f is continuous between a and b. Now the conclusion says that the integral from a to b of the function will be equal to the function with c plugged into it times the difference between a and b. And we have to find that c right here. So first we're going to integrate this. So I'm going to rewrite it, 9x to the negative 3, and integrate that. So to integrate this, we add 1 to the exponent, negative 3 plus 1 is negative 2, and divide by the new exponent, so we get negative 2. And we're going to evaluate that from 1 to 3. So instead of putting plus c, we're going to put our integral limits from 1 to 3. I'm going to rewrite that. So it's negative 9 halves, and then x squared in the denominator, from 1 to 3. So we have negative 9 over 2 times 3 squared, minus negative 9 over 2 times 1 squared. So negative 9 over 18 plus 9 over 2. That's negative 1/2 plus 9 halves, which is equal to 4. That's 8 halves, so that's 4. So the mean value theorem guarantees that somewhere there's a value here that will make this side equal 4. So let's plug in what this side is. We've got f of c, so that means you take the c and you plug it into the f function. So f of c will be 9 over c cubed, and b minus a is 3 minus 1, so that's 2. So the mean value theorem says that 4, which is the value of the left side, will equal 9 over c cubed times 2. So that's 18 over c cubed. We have that equal to 4, so multiply both sides by c cubed, you get 4c cubed equals 18. Divide by 4, you get c cubed equals 9 halves if you reduce it. And then we need the cubed root. Remember when you're typing in the cubed root that you use parentheses. Oops, 9 divided by 2. And always round to 3 numbers after the decimal if it's your final answer, or 4 if you're going to use it for something else. So the value of c is the x value. that's in between 1 and 3. Always check to make sure it's between 1 and 3. That if we found the area of that rectangle represented by that x value of 1.651, it would be equal to the area under the curve from 1 to 3, which is 4. The other new concept in this section is the average value of a function. If a function is integrable, so you can take the antiderivative between a and b, then the average value of the function is just the antiderivative of the function from a to b times 1 over b minus a. So think about what the average is. If you want to find the average of something, you add everything up and then you divide by how many there are, right? So think about what this is. This is the area, or the value if you want to call it that. And if we want to find an average value, we divide by like the number of rectangles. So we're dividing by the number of the difference between a and b. Remember, our integral from a to b of a function finds the area between a and b under the curve. So it's like we're dividing by the distance from a to b. So that's how we find the average value, okay? Don't confuse that with the average rate of change. So when they ask for the average rate of something, you're just going to do boring old slope. But if they ask for the average value, and they could ask you for the average temperature, the average cost, whatever this integral stands for, so they're just using the word value as a generic word, but be prepared for things like average temperature, average value, average cost, average profit. You'd take the integral of your profit function, the integral of your temperature function, the integral of your cost function, and then multiply it times 1 over b minus a. So let's do an example of that. From the average value of this function of cosine on the interval from 0 to pi over 2. So average value, I know I'm going to do the integral from 0 to pi over 2 of cosine of x, but multiply that times 1 over b minus a. And b is pi over 2, and 0 is a. So I'm going to multiply my integral times 1 over pi over 2. And the integral of cosine is sine. So I'm going to evaluate that from 0 to pi over 2. And then remember to multiply that by 1 over pi over 2, which is 2 over pi, because you multiply by the reciprocal. Dividing by a fraction is the same as multiplying by a reciprocal. So I have 2 over pi times sine of pi over 2 minus sine of 0. Sine of pi over 2, unit circle, pi over 2 is up here, sine is 1, sine of 0 is here, which is 0. So I have 2 over pi. That's the average value of the function. Your homework, page 293, 293, 45, 50, and 51 to 63 odd. Quiz tomorrow, remember, on 4.1 to 4.3, not including 4.4.